So this is for FOM 11, Chapter 5, Section 5, the introduction of z-scores. It says here, z-scores are the number of standard deviations a data item lies away from the mean. And of course, that just means away from the average. So the standard normal distribution, a normal distribution that has a mean of 0 and a standard deviation of 1. So this is just a recap of yesterday or the previous lesson. We talked about the bell curve, and the bell curve has a mean, and we used mu. Well, this time what we're saying is mu is equal to 0. And then the standard deviation of plus or minus 1. We talked about the area between these two dotted lines is 68% of all elements. And then plus or minus 2. Standard deviations, we said that that was 95% all the way down. And then plus or minus 3 standard deviations. That was approximately, I think it was 99.7% of all the area. Okay, so we're going to use that information and we are going to calculate some probabilities. So let's take a look at example number 1. It says the marks of two classes are normally distributed with a mean of 70, but class A has a standard deviation of 4 and class B has a standard deviation of 7. Suppose Larry was in class A and got a mark of 78. Willie was in class B and also got a mark of 78. How did each perform relative to his class? So we're going to do class number 1. So let me just change the color. So, or sorry, I say class A. It says here the mean of class A was 70 and the standard deviation was 4. So if you wanted to, you could draw a bell curve. And we said that the mean was 70. So one standard deviation, that would be 74. Two standard deviations, that would be 78. And so it says here Larry was in class A and got a mark of 78. Well, that means Larry earned 78. That means he beat everybody below. He beat everybody below him. Well, what is the percentage of the members in his class that he beat? Well, in our previous lesson, we know that this area here was 34%. This area here in the next standard deviation was 13.5%. And of course, he beat everybody below the average, which was 50%. Well, Larry would have beaten 50 plus 34, that is 84, plus 13.5, that is 97.5%. Right? So it would be he beat 50%, plus he beat another 34%, plus he beat 13.5%. And just to make sure that our calculations are correct, I'm going to take my calculator out, and that's going to be 50 plus 34 plus 13.5. Yeah, so he beat 97.5% of the kids in his class. Now, class B. I'll use a different color. Class B. Class B had standard deviation, class B had a mean of 70, No, marks of two classes are both normally distributed with a mean of 70, but class A had a standard deviation of 4 and class B had a standard deviation of 7. So it's the same mean. So I'm going to draw my normal distribution. So again, it's the same mean, but the standard deviation in this case was 7. So the first standard deviation is 77. The next one would be 84. Now Larry got a mark of 78. So Larry got a mark just slightly above the very first standard deviation of 78. That means Larry beat everybody below the average, plus the very first standard deviation, plus a little tiny smidgen. Well, we know this probability below the average is 50%. We know that Larry beat at least the first standard deviation, that's 34%. And a little smidgen, well, we don't know exactly how much that smidgen is, but we can say, I don't know, a couple of percent. So let's say 50% plus 34% plus, I don't know, I'm just going to guesstimate another 5%. I'm going to use my calculator. What does that work out to? That's going to work out to 50 plus 34, and then I'm just guessing that little tiny sliver here, okay, an extra 5%. So he only beat roughly 89% of the class. Okay, so in class A, he was like one of the top kids. He beat 97.5% of the kids. In class B, with the exact same mark, he only beat 89% of the kids. So we have the ability to calculate what's called a z-score. Now, a z-score is basically the actual score that you earned minus, for this case, the class average divided by the class standard deviation. Okay, so from now on, we're going to use this formula. All right, so let's move on to the next example. It says here, IQ scores are normally distributed with a mean of 100, so that's important, and a standard deviation of 15. Can you sketch a normal curve showing 68%, 95%, and 99.7% of the data symmetric about the mean? So whenever it says sketch a normal curve, what we're going to do is we're going to graph a bell curve. All right, at its peak, that's the mean. Now in this case, the mean is 100. Now we have plus or minus 1 standard deviation. Well, what's the value of the standard deviation? Oh, it's 15. So plus 15, that'll be 115, minus 15, well, that'll just be 85. Plus or minus 2 standard deviations, well, that's going to be 130. I'm going to minus 15, that's going to be 70. So that's 2 standard deviations. And then plus or minus 3 standard deviations, it's going to be roughly 145 and then 55. Okay. Now we know that this area between these 2 points totals up to 68%. Between an IQ score of 70 all the way to 130, that's going to be 95% of the population. And then plus or minus 3 standard deviations, I apologize for the overlap in color, that's going to be roughly 99.7%. So it says, what proportion of the population has an IQ between 85 and 115? So I'm going to use my highlighter. That's between 85 and 115. Can you guess what that would be? Well, I hope you guessed 68% of the population, right? It lies everything that's highlighted in yellow. It says, what's the probability that a random person has an IQ less than 85? I want to know what's the probability that somebody is to the left of 85. So it's highlighted in green. Well, there's a couple ways to do it, but I think the easiest way to do this is hopefully you recognize that everybody from this point on to the left, it works out to 50% of the population. Well, if that is worth 50% of the population, this particular portion right in here, isn't that worth 34%? Just this part that I'm highlighting in red? Well, if the whole total is 50% and we've already accounted for 34, everybody to the left of 85, the area in green, well, that's only going to be 16%, right? 16% plus 34% works out to a total of 50. Now, it says, what's the probability that a random person has an IQ less than 72? It says here our boundary score 72 does not fall in a convenient multiple of a standard deviation. It's not one whole standard deviation below or two whole standard deviations below. Well, this is where that z-score formula comes in handy. So let's calculate the z-score. So the formula for z-score is x minus mu over sigma. So we're looking for what's the probability that its score is lower than 72. So we're just going to pretend that it is 72. So it's going to be 72 minus, what was the mean? So I'm going to take a look at our example. Our mean was, oh, it's right here, 100. And our standard deviation was 15. So what is 72 minus 100 divided by 15? Now, using this formula, we are going to find portions of standard deviations, right? So 72 subtract 72 subtract 100. Oops, typo. 72 subtract 100 divided by 15. So it's negative 1.8666 standard deviations to the left. Negative 1.866 standard deviations to the left, right? Number 72, well, that's somewhere right around here. So it's a little bit more than one standard deviation, but it's definitely less than 2. And what we did was we calculated it. It worked out to negative 1.86 standard deviations. Now, there's a table. It's called the standard normal table, and you can find that on the web, and I've already done that. Here it is. Let me just open up the actual photo itself. You can look that up on Google. That's all I did. And here is what's called a Z table. Now, the way you read this is there's actually a vertical column, which is up and down, okay? A vertical column, which is up and down, and a horizontal column at the top. Now, the vertical column up and down gives you an accuracy of only to 1 decimal place. Notice you've got Z values that are negative 3.4, negative 3.3, negative 3.2. But if you wanted a little more accuracy, well, you would then start looking to the right. So let's take a look. We have negative 1.86. Where can I find that on my table? Well, I would look for negative 1.8. So I'm going to go down, 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 down. Oh, there's negative 1.8 right there where my cursor is. How would I find negative 1.86? Well, here is negative 1.81, right? You see this 1 here? So I would match up these columns, and I can't really write on this picture, but it's negative 1.8. I'm going to go all the way to negative 1.86. There you go. So it says the area, right? Notice that up here. Notice that up here, it's all the area to the left of whatever your Z value is. So it's negative 1.8, and I'm going to go to the 6th column, so it's 0.0314. So that's the area, 0.0314. So it's going to be 0.0314. If you wanted to know a percentage, you would just multiply by 100, and we would say roughly 3% of the people have IQ of less than 72. Okay? Now, here is how we did it before. It says you convert 72 to a z-score, which we just did, and draw it on a normal standard curve with a mean of 0 and standard deviation of 1. So what this really means is if we were to draw a bell curve, by using the formula, all we're doing is we're readjusting and we're pretending that Our mean is now 0. We have a -1 standard deviation, a -2 standard deviations, but when we did a calculation, we got a calculation of -1.866. And we want to know how many people are to the left of this. So here's just a quick, tiny shot of our table. Here's -1.8. Again, this table is slightly different. It has on our horizontal line here, it's -1.89, -1.88, -1.87. The one that I showed you has it written backwards, but it's the same idea. So here's -1.8, and then we would go all the way down to -1.86, which is this guy right here. Okay, it says here, therefore, -1.87, they rounded it up, corresponds to an area of 0.0307, and you multiply that by 100 to get 3.07%. Okay, therefore, the probability of an IQ of less than 72 is less than 3.07, and in my worked out example, I have around 3.1%. Okay. It says here, what's the probability that someone has an IQ of 140 or more? So we're going to convert this into a z-score. So here we go. Z is equal to x minus mu over sigma, which is 140 minus 100 all over 15. So that's going to be 40 divided by 15. We're going to calculate the z value. I'm going to take my calculator out. This is 40 divided by 15. That's 2.66 standard deviations. 2.6, we'll round up to 2.67. So I'm going to go back to my table, 2.67. And so notice that these values, well, these are negative z values. What we just calculated was a positive z value, so there must be more. So I'm going to scroll, and there you go. Okay, so where's -2.67? Well, I'm going to go -2.6 on my vertical column first. 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. In order to get to 2.67, I'm going to move to the right until I get to the 7th column. And it looks like 0.9962. Okay, so that's the area, 0.9962. And if you want a percentage, you multiply that by 100, and you get 99.6%. So it says, what's the probability of someone that has an IQ of 140 or more? Well, this is the population that's 140 or less. So the only way you can get the area that's greater than that, it's going to be 100% minus 99.6%. which is approximately 0.4%. That means there's a very, very small population that has an IQ greater than 140. Okay? Right? So I just want to make sure, 99.6%, when we first originally calculated it, it was everybody that has an IQ of 140 and below. But the question says above or more. So you want to find the area to the right of the curve this time. The only problem is the table, all right, the z-score table gives you only areas to the left. So you need to make sure you remember that. All right. What is the probability that someone has an IQ between 90 and 110? So because we're looking for the area in between, we have to do two different calculations. All right. So an IQ of 90, what we want to do is I'm going to draw a little standard normal. And we said that we know that the mean is 100, and what we're really interested in is finding somebody that has somewhere between 90 and 110. We really want to find this area in between. The only way to do that is we're going to separate this into two problems. We're going to draw the standard normal. We know that the mean is 100, and we're looking for an IQ of 90. The only problem is when we convert it into standard normal, it only gives us the area to the left. That's not what we want. Okay, so we have to do this into two problems. So here's the second part. We have the normal. The mean is 100. And we're looking for an IQ of 110. But again, in our table, it only gives us the area to the left. So what we're going to do is we're going to find the area to the left of this particular problem, subtract the area to the left of this particular problem, and when you do that, you end up getting the area in between. So let's go ahead and do that. So I'm going to do the z-score. I'll do this one first. Z-score, that's going to be 110 minus 100 over 15, which is 10 over 15, which gives you a z-score 0.666. I'm going to do the second part of the problem. It's going to be 90 minus 100 all over 15, which is negative, right? It's negative 10 over 15, which gives you a negative 0.666. Well, I'm going to take my table out, and here's my table. Positive 0.67, right? 0.666 is going to round up to 0.67, and it works out to an area of what looks like 0.7486. 0.7486. Okay, now I'm going to find the area to the left for an IQ of 90. We got negative 0.666. So I'm going to take a look at my table. Negative values are on the other page. So negative 0.6, well, that happens to be down here now. And it's going to be 0.67. It's, if I read this right, it's 0.2514. Now, to find the area in between, what I'm going to do is I'm going to go 0.7486 minus 0.2514. I'm going to use my calculator, and if I'm extra careful, I should get the right answer. 0.7486 minus 0.2514 gives me 0.4972. Now, if I want to know the percentage of the population, I'm going to multiply by 100, and that gives me 49.72%. Now, what does that mean? I'm going to highlight this one because this is my final answer. It means that the probability of finding somebody that has an IQ on the low end of 90 and an IQ on the high end of 110, well, that's about 50% of the population. Now, the last one says Crunk has an IQ that is exactly 45% of the population. What is Crunk's IQ? So we know that someone has an IQ that is higher than 45% of the population. Well, the only way to know that is I have to look at my z-score. And again, these values inside my table are probabilities. So I'm going to take a look at a probability. I'm going to take a look at a probability that is 0.45. Can you find it? Here's 0.42, 0.41, 0.41. Oh, it looks like it's going down. Oh, here we go. Here's 0.42, 0.42, 0.43, 0.43. Where's 0.45? Oh, here we go. It's somewhere between a z-score of what looks like negative 0.1 around negative 0.12. So Z is equal to x minus mu over sigma. This is what we're looking for. We're looking for this guy. We know that the Z value that would give you 45% is negative 0.12. So I just want to make sure you saw that. Okay, 45%, that's 0.4522. Well, the way you read that is negative 0.1, and another decimal of accuracy would be negative 0.12, is equal to the IQ that we're looking for minus the average divided by 15. Now this becomes just a basic algebra problem. How do I get rid of fractions? Well, I multiply both sides by 15, right? So this becomes, I'm going to take my calculator out, 15 times 0.12. It should be negative, so it's negative 1.8. So it's negative 1.8 is equal to x minus 100. Well, what do I do next? I add 100 to both sides. And then this becomes 98.2 is the IQ that we're looking for. I apologize, this video went a little longer than I'd hoped, but hopefully it makes sense.